Our next speaker is Jan Gorzny, and he is the co-founder of Zirkit. He is going to talk to us about the sequencer of tomorrow. Please step up.
Thank you. Thank you. Nice to be here. It's good to be back at ETHWarsaw. I really like it. I like the new venue. It's great. Anyways, let's get into it. So my name is Jan. I am a co-founder at Zirkit, and Zirkit's a zero knowledge rollup that just went live in sort of mainnet in the summer. And this talk is not necessarily going to be about Zirkit per se, although there's a little bit in there, but really to get people here onboarded with what sort of buzzwords are going on in the layer 2 sequencer space. So if you've been following recent developments in layer 2s, a lot of them are trying to differentiate themselves in different ways, right? They're trying to get their own market share, they're trying to innovate in new ways, they're trying to do some cool stuff. And while they're doing this, they're inventing new terms and they're coming up with new concepts and they're changing how things work. And that's really confusing to a lot of people, including myself. I've been in the space for 5 years. And when people start talking about base sequencing, I'm like, oh, well, I heard about this idea, but what does it really mean? And things like this. So I wanted to give this talk to sort of clarify some of these terms for some people who are new to the space and to go into some of the details and sort of talk about the things that excite me a little bit about sequencing and the innovations there. So that's sort of already what this slide is, which is basically I'm going to talk to you about some of the innovations that have happened in rollups over the last probably year-ish, maybe year and a half. Some of the ideas are certainly much older than that, but now they're sort of maturing because in the past 5 years, rollups came from this sort of idea that, oh, we could do this too. Oh my God, they're here, they're working, right? You heard talks now, even like people trying to bring it to Bitcoin, Starks versus Snarks, there's a whole bunch of stuff. Like they've matured. And so as they do this, they're evolving, things are changing. And certainly it's important that we know how they're changing, why they're changing, and enable users like yourselves or developers like yourselves, depending on what you are, to build on or use the appropriate rollup for the things that interest you, right? If you care about decentralization, maybe there's a rollup that really, really does that really well. You want to focus on that. If you care about other things, maybe there's something that you want to pay specific attention to, right? So different languages being used on the network or something like this. So I'll talk a little bit about what a rollup is, just so that we're all on the same page. If you've been in the space for a while, you probably know what all of this is, but I have to make sure that if you haven't been in the space in a while, you know what's going on. And then I'm just going to talk about some of the trends that have been going on in this space. So in particular, we'll look at decentralized sequencing and base sequencing, shared sequencing, different things you can do on the sequencer, and then sort of what's still left to come. What would we love to see, I think, as an ecosystem and as specific projects over the next couple of years to really make rollups sort of your own and make it useful to what you want to do. So first, what's a rollup? Well, a rollup is sort of a way to take a blockchain and sort of cram it into another blockchain. What we're going to do is we're going to take some blockchain and we're going to say that its state will occasionally be anchored to another rollup, typically, and say that at some point, the underlying rollup, the layer 1, like Ethereum, will have some sort of say in what the rollup network is considered as final. And so essentially, we'll take the second blockchain, the layer 2, build it on top of Ethereum, the layer 1, and say that the layer 2 is only final if the layer 1 sort of sees some things happen. And so what we can do is separate the computation of the layer 2 blockchain off of the layer 1 itself, and we can build layer 2 blocks and occasionally just post the state updates for those layer 2 blocks onto the layer 1. So typically this works through the process of sequencing the layer 2 blocks. So we collect some transactions, we build layer 2 blocks. Often they look like layer 1 blocks because right now everyone really wants sort of an EVM compatibility or equivalence. This is kind of a good goal because you have a lot of ETH developers. So if you can just have their smart contracts port over and everything works, it saves costly audits, everything just works out of the box, it's really nice. But as we'll see, there might be other ways we want to do that. But anyways, you build these layer 2 blocks. They look like layer 1 blocks. Occasionally you write them onto the layer 1 itself, and then after some conditions are met, you say, okay, they're final because the L1 says they're final. And in an optimistic rollup, this might be something like a timeout that hasn't been challenged. So you post a layer 2 block and no one says you've made stuff up in that block or cheated about the transactions. Or in a zero-knowledge rollup, you could do something like provide a validity proof that says, actually, the block was constructed, and I definitely didn't cheat because here's a mathematical proof. But either way, at the end of the day, your layer 1 sort of has some say in what is considered final. Today, though, we're going to talk about not the finality part, which is now more or less solved, although there's still work to be done, and there's probably edge cases on what happens if things go down or things like this. But we're going to talk about the sequencing part. So how do we actually build the layer 2 blocks? And what does that mean, and what can we do differently? And what are the implications of changing this piece of code that is actually common to every rollup, regardless of if it's an optimistic rollup or a zero-knowledge rollup or something else entirely. So, to be clear, we'll talk about the sequencer that builds blocks, and it can take inputs from 2 places in particular. It can take transactions either from sort of the layer 2 network itself, so you can configure your wallet like MetaMask and say, I'm going to send my transaction directly to the layer 2, and I'll pay for fees and all of that. But typically, you need to get some assets onto the layer 2 itself, and you do that through a bridge or from the underlying layer 1. And so you can also have transactions, which we'll call deposit transactions, that come from the layer 1. Not always a deposit per se, but this word has become conflated with this. So from the sequencer, from the sequencer, we'll build blocks, and occasionally we'll do some other stuff with the block. So we come up with a block, which people have different models of what a block is in layer 2. If you look at L2Beat and you sort of look through all the rollups, some people have blocks that look like Ethereum blocks. Others have blocks that contain only one transaction. So they're kind of different, but at the end of the day, you have something that looks like blocks. And you might also get the sequencer to publish some data, like the transaction is going to put in the blocks or the batches, so that if you don't want to wait for a finality mechanism, you have some commitment that actually, this is what the blocks will look like, assuming the sequencer is honest. This is called a soft commitment. It's the first arrow downwards there. Afterwards, if you do wait for the finality, you get the hard finality. So you can't go back once you get the hard finality. But the sequencer generally gives some nice heads up so that people can be assured that actually, if everything goes right, the transaction is going to sort of execute and will be good. So it doesn't have a huge job. Basically, it just needs to take transactions. It needs to produce blocks. It looks like Geth, right? Proof of stake, where you only had one client, you just had something like Geth. And in fact, a lot of the sequencers look like this, but they're augmented with some other things to say, get deposit transactions from the layer 1 to sort of parse those blocks and build that. But that's all they do. They build blocks. That's the key thing. And now we can change them and do other things with them. So, I already talked about this. I'm sorry. So sequencers do exactly that. They sequence. I'm going to skip this slide. Maybe we'll catch up on some time anyways. So how can we change them? Well, we can change them in a couple ways. One thing we can do is say, well, we have multiple networks, layer 2 networks. You have like 30 right now that are currently live on L2Beat, I think. I think another 70 are in production or something like this. Somewhere around 100, a little over 100 in production or currently live. And maybe actually you don't want to be always changing your endpoints to some of these things, right? Maybe what you want to do is say, I'm going to just send all my transactions to one spot, and maybe it'll go on one network, or maybe it'll go on another network, depending on something else. More or less, you can do that. You can have a sequencer that's responsible for building blocks for 2 networks simultaneously or more. For now, I think 2 is a good starting point. There probably will be more in practice. This is the notion of a superchain that the optimism people are sort of pushing forward. So unsurprisingly here, the colors are sort of red and blue, red for optimism, blue for base, both of which have the same underlying infrastructure and code, and both of which are moving towards a superchain where they'll have a single sequencer that builds both blocks. Or at least that's the idea. That's what they've been writing about. The implementations might differ, but that's certainly the goal. And what this means is some really cool stuff. First of all, they have really easy time developing their network because they don't need to build all of this from scratch. They just fork Optimism and say, hey, we're on board with you guys. We're going to use your sequencer at some point. We'll make sure we're always compatible and everything just works. Our blocks will look like your blocks, et cetera, et cetera. And what this means is that in the future, they could actually get some really nice perks. If you have transactions that originate on Base and then go to Optimism and they have a shared sequencer, well, the sequencer can sort of be instructed or coded in such a way that you make sure that those cross-chain messages are actually always in the same block, for example. So you can force atomicity. And this is really cool because now you can do things that you probably can't do if you have different sequences you need to talk to because latency is existing in other places that isn't existing here. You could also reduce MEV in some way between these networks. You also have really nice liveness in the sense that if one network sort of is up, the other one is also always going to be up, right? And you can share things like escape hatches and things like this. And the infrastructure, coding it and actually running it also gets very, very easy. You can just point your MetaMask to a single sequencer and everything just sort of works. The downside is maybe on base, they don't want to do this, but maybe your next chain on the superchain wants to extract MEV. In this case, the sequencer is working for a number of chains, so it doesn't necessarily have any incentives to sort of bias your particular MEV concerns. Now, maybe you could bribe it or do something, but that's certainly not the goal of the superchain. Maybe other ones will do it differently. And the other downside is if you have very disjoint networks, you're going to have a hard time sort of sequencing them, because the sequencer sort of benefits from shared infrastructure. If you start changing what the networks look like, you have to do a lot of work to the sequencer, in which case maybe it doesn't make sense to have a shared one to begin with. So you can have shared stuff. That's pretty cool. You can also do other things. You can say, I don't want to be responsible necessarily for ordering all of my transactions as a sequencer, because I am unreliable. And what you maybe trust more than a sequencer, which may be centrally operated, is the underlying layer one itself, like Ethereum. And so you can say, actually, Ethereum, you come up with the blocks for my layer 2. And as you come up with them, I will build my layer 2 out. And if you're clever about this, you can still get performance gains. Everything can still be cheaper, all of this. But what you really, really get out of this, which is very nice, is the ability to have very strong liveness guarantees. As long as your layer 1 is operational, your layer 2 is also operational. And if you do this in particular ways, you don't need to worry about sort of emergency functionality. You don't need an escape hatch if your network is down, because, well, your network's never down. Either Ethereum's down, which is bad for all of us, or both networks are always up. And that's really, really cool. So one team that's looking at this, and they've started doing this, is Tycho. If you've seen them, they have a smart contract where you can propose layer 2 blocks, and it builds it that way. There's sort of some caveats here with the pluses. They say simplicity and cost. I don't know right now that either of those are strictly true. Tycho is one of the more expensive ZK rollups to operate, according to L2Beat. But in principle, it's got a really nice design mechanism, and it should go down once we have some really good, proposer-builder separation type things, in order to prevent sort of wasted execution of proofs or block generation and things like this. But you can certainly do this, and what this also means is that your sequencer can be sort of decentralized, because if you're just calling a smart contract saying, take this block and put it in my L2, if you don't restrict who can call that function in the smart contract, boom, you have decentralized sequencing and permissionless sequencing, which is really, really cool. The downside is you might not get MEV again, because maybe your block will be included by the layer 1, maybe it won't, maybe it'll take someone else's, depending on if there's a wasted effort in rebuilding these blocks. And again, you're probably going to get constrained sequencing depending on how this is built out and what needs to be done by the L1 to actually build the L2 blocks. But this is really, really cool. There's also related notions of sort of pre-confirmations and sort of a lot of cross-chain atomic swaps that can come with base sequencing if everything sort of works. But first, we got to make sure that we have a really, really strong contender for a base sequencer that's actually cheap and useful. And people work on this. It's really exciting. But certainly it's still a fairly new concept. Just like shared sequencing, it's not quite sort of full mainstream developed. There's stuff to be done still. But if you want to take a simpler approach and you still want to have a centralized sequencing, you can also change things, right? One easy way you can do something is change the language on your layer 2. Right? Solidity is really cool. Everyone loves Solidity if you're on Ethereum probably, but maybe actually you want to use Cairo. Starknet did this, right? Maybe you want to use C++. Maybe you want to use Java. I don't think anyone wants to use Java, but like you could do anything you want. And once you start controlling the sequencer and actually changing your VM, you can change a lot, not just the language. One thing we're doing at Circuit is adding this notion of sequencer level security, where actually what we're going to do is we're going to have a system in place where we can look at layer 2 transactions as they come into the layer 2, and if they seem to be problematic, we'll put them in quarantine. And so what we're aiming to do is change how the VM works in order to prevent malicious transactions from hitting our chain. And this affords everyone who uses the chain, either as a user or as a dApp developer, an extra layer of security they get for free. So at Circuit, we can look at the transactions, figure out if they're bad. If they're bad, we'll not put them on the chain, or at least not put them in the chain right away. And that means people's funds are more secure. Of course, there are considerations for this. For now, it starts with a little bit of centralization. We need to make sure that we're on the same page about what good and bad is, and there needs to be good performance. But certainly, there's an opportunity to save people lots of funds, right? Even if a dApp, doesn't do their sort of homework and get an audit, or has bad engineering practices, we could guard funds within that dApp, which is really cool. Now, I'm not saying do that. Please, if you're deploying on Zirkit or anywhere else, get an audit. Build your dApp as securely as possible. But of course, we can help if you don't. Taking a step back, the holy grail of most of it, this ecosystem is decentralization. Base sequencing is one way to do that, but there's other ways you can do this. People like the team, I think, at Espresso are looking at other ways to sort of more traditionally introduce consensus mechanisms into a sequencing system. So instead of having a single sequencer that, say, we run or someone else runs, you could ship the code on GitHub and have anyone be able to pick it up and run it, and then they talk to each other under some specific consensus mechanisms. And if that's performant enough, and if that makes the right economic sense, you can also do this in a way that doesn't necessarily rely on the layer 1 to produce the layer 2 blocks. And so in this case, decentralized sequencing is actually just more general than base sequencing. So base sequencing is decentralized sequencing, but decentralized sequencing isn't necessarily base sequencing. Probably, there will be some strong ties there. But if you do this, you get strong liveness guarantees, because if your sequencer operator ever goes offline, you just spin up a node yourself and you say, oh, network's back up, we're good, right? And as long as there's no barriers to entry and everything runs and you don't need specialized hardware, this is also quite nice. The downside is people have been thinking about this for a while. It's very complex because you're introducing consensus back into the system, which case looks like an L1, in which case looks kind of slow because you need security. So there's stuff to be done, stuff to work on. But people are working on it, people much smarter than me, and I'm really excited to see it come to the future. But you can do a whole lot more than that too. Sorry, I don't know if the mic's been on the whole time. I hope so. You can do other things with the sequencer too. We talked a little about MEV. You could build a rollup where your goal is to take as much MEV off of your sort of network users and put it into your own pockets. I don't know if you'd want to do that. I don't know if the ecosystem would want you to do that. But certainly you could build MEV extraction into it. And then maybe you could pass that back to your users in the form of cheaper fees or offsetting costs for publishing data to your L1 or wherever you store it. But you could do this. People have talked about this. I don't know of any teams actually working on this, but it would be really cool if it did exist. I don't know if there's a good market appetite for it, but it'd be a nice technical challenge. You could do other things like fair sequencing. Base sequencing allows you the opportunity to always have sort of strong liveness concerns about being able to sequence layer 2 blocks whenever you want. But what if you want to be fair? What if you wanted to do the opposite of an MEV boost and say, I definitely don't want someone to be able to sort of craft blocks in such a way or submit transactions in such a way that they can profit unfairly? Maybe you can put your sequencer behind a zero-knowledge rollup, a zero-knowledge proof framework that says, the sequencing algorithm is always doing this, and that algorithm is fair, therefore the sequencer is always fair. I don't know if that's easy. I think it'd be really cool if people could do it. Of course, if you also start looking at where the transactions come and go from the sequencer, you could talk to other chains. Shared sequencer affords you the ability to do atomic swaps between networks that you sequence, but that doesn't mean your inputs sort of only need to be tying to one layer 1. Maybe you could also read from different layer 1s, in which case you're still anchoring on one of them, or maybe you're not, I don't know. But maybe you can do some kind of, maybe not always atomic cross-chain messages, but some cases maybe you can get some benefits, right? So if you do some messages from Binance and others from Ethereum, maybe there's some way you can make them really tight, and there's some good use cases for that. I don't know. And the last thing that probably really needs to be talked about is still the notion of what happens if your sequencer is offline. You don't want your network to go down, so if you're not a base sequencer, you probably still need to do something, and in the past, sort of we called these things escape hatches, or more sort of accurately these days, forced inclusion mechanisms. So if your network sequencer goes down, you still want to be able to sort of update your L2 state, especially as it sort of implies the ability to get your funds out of the network if the network is down. But there's also a whole lot of other stuff you can do. So you can change the block size, you can work with pre-confirmations, you can do a whole bunch of other stuff. In short, the sequencer of tomorrow is going to be very different than the one we're seeing today. Right now, it's all about EVM equivalence and a couple little buzzwords that sort of say, I'm doing this a little bit differently, or I want to do something cool. But they're still immature. There's a lot of work that needs to be done for most of these networks. Shared sequencing, for example, has been talked about, but I don't think the atomic ability to send cross-chain messages is there. So when you start looking at these buzzwords, I want you to be cautious of what they are and what they're promising to be. because there's often a very big discrepancy. And so step 1 is figuring out what they should be, and then step 2 is figuring out what they actually can do. And then step 3, if you've got time or you got a research budget or you want to hack something together, is figuring out what they should do for you in the future and then building it out, because that's also really, really cool. When we have hundreds of rollups, having 80% of them do exactly the same thing probably isn't going to be that interesting. You're probably going to need 20 or 30 of those, and beyond that, sort of kind of useless. So do cool new stuff with your sequencer. Take some bold risks. You can do stuff where only your community needs to be really, really invested in it, because you don't need to target all of the Ethereum ecosystem share. And that can still result in some very big pieces of the pie for you, but also doing something really cool and interesting that some people could find very, very valuable and useful. So in short, take a look at these things, keep building them, and keep paying attention to what they are and what they should be. Thank you.
We have time for one question while we get our next speaker set up. Who's got a question for Jan? Questions? Yes, I will hand you my mic.
The sequencer should work only with the same EVMs, or it could be...
Sorry, repeat the question. Did you say shared sequencers only work with EVM?
With the same EVM style, if it's Ethereum EVM, or I can just do sequencing between Solana, Sui, to Hyperliquid kind of stuff?
On the engineering point of view, I don't see why you couldn't change to support multiple VMs. Obviously, the more different they are, the more engineering work that will take. And maybe there are some properties that will conflict across certain things. I can't think of any in principle, but I think it's mostly an engineering function. So if you want to spend the time figuring out what it means to make an atomic swap between a Solana VM and Ethereum VM, and then put that in a sequencer, I don't see any fundamental reasons why that wouldn't work.
Just technical.
Just work, yeah.
Great.
Okay, so thank you.
Thank you so much. Please give another big round of applause for Jan.